So the Databricks data live tables and DB-SQL teams make data engineering declarative. Yannis, and I will give you here a taste of the product and of the many interesting research challenges that met in this area. So let's start. What is data engineering? It is the task of deriving comprehensive, clean, and recent data for follow-up, ML, and business intelligence. Data engineering is very messy. It is not glamorous and it is messy. And the Data Live Tables team took the goal of making dead simple to code and manage reliable data pipelines. And the code was delivered with declarative pipelines for ESD. A declarative pipeline is essentially a DAG where the sources of the DAG accomplish are ingestion tables, technically streaming tables. We accomplish the ENL part of extract, load, transform. And then we have follow-up downstream processing where materialized views transform. Typically, the code of both the streaming tables and of the materialized views is SQL. You see here samples, though Python is also possible. In this example, you see a snippet where a streaming table raw data is ingesting from some cloud storage location JSON files incrementally, and then the materialized view comes up to do some kind of transformations that are not written there that clean this up. Now, we want declarative pipelines to be for data engineering what SQL was for query processing. That is, like SQL, with declarativeness, you achieve simplicity, automated optimization. Plain SQL definitions, plain simple SQL definitions, we are not alone in doing this. They are becoming actually very popular right now. For example, the DBT open source has a big follow where people are writing transforms just in SQL. The additional perspective that we bring here is that we are saying, hey, look in the automated optimization opportunities that appear in these declarative pipelines, because there is a lot of things that you can do if you come closer to the engine. I'm going to give you a taste here of two things. The first one is the enzyme incrementalization planner. So this is to incremental maintenance of materialized views, what an optimizer would be to SQL query processing. It receives the logical plan of the materialized view. It sees the changes that happen and comes up with the optimal incrementalizing flow, where an incrementalizing flow is a sequence of steps that incrementally maintain the materialized view. It does this by employing heuristics and cost metrics. Notice there is a lot of SQL that users use in specifying transforms. Thus, a lot of SQL has to be incrementalized, and also let's not lose focus on simplicity. Simplicity requires that we cannot ask the users PhD questions about what SQL can be and cannot be incrementalized. There is an earlier component in a decomposer that is actually solving this problem by splitting under the hood MVs into the incrementalized part and the fully reproduced part. A second opportunity is holistic pipeline optimization. You can reduce greatly the costs and or the latency by looking at the data flow graph on this DAG as a whole, and we already see 50% gains. So I gave you today a taste of database performance opportunities. Tomorrow there is a sponsor talk where I'm going to go tangential areas, very interesting tangential areas. We will see how software engineering practices intersect with declarative pipelines and allow you to manage the process as well as manage data quality. We will go into the intersection with systems and talk about enhanced auto scaling, where the user does not have to worry about how much to provision and all of the stuff. So I hope I'll see you tomorrow. I think it is 10 o'clock, and looking forward to your questions, perhaps offline, because we are out of time.